preparation of rock sample. But the determination of uniaxial compressor strength of the rock sample. How find strength of tendon strength of shear strength of find the strength. So these are the other additional rock force. So here the rock sample, aim of preparation of the rock sample for the laboratory purpose, collections and storage of the samples. Hypertensions, what of the largest layer of for the testing of the rock properties, strength, porosity, etc. Find the balance, behavior of the rock, stresses, mind operations. Size and shape of the samples. Sample can be shaped to cylinder or cubical. The size of the sample, well, for the rock samples, different thicknesses for test material is normally collected from the field, form of the samples are collected from the sample for sampling. So, so this is exactly field collection of samples. So this is the four collections in a portal. These are the four barrels, the collection of the samples. So this get the this type of course, samples, course of course. This is the simple box, core samples box shown here. Collected, also they mentioned that material where collected for drilling missions. Heavy duty pillar type frames with 2 HP single phase AC motor wearing a cutting feed provided the water feed. Swivel lid with can be connected to suitable water supply. Provision is at the base for the water connections, drainage, for preparation from the regular and irregular samples oversight, EX to NX, clamping arrangements to be had specimens with the regular, irregular shapes to the base of the mission. Four cutting speed 600, 800, 1100, and 14.5 speeds. Field samples procedure should be rational and systematic. And the material should be marked to indicate its original position and orientation related to identifiable boundaries of the parent rock mass. Ideally, samples should be moisture proofed immediately after collection of the either by uh, waxing, spraying, or barking a polyethylene bag or a sheet. For moisture proofing by the waxing, the following procedures can be used for core that will not fill apart in the handling. Wrap core in a clear the polyethylene, such as a gland wrap or a sharp wrap. A wrap in the cheese cold clothes. Coal wrappers pour with lukewarm wax mixture of approximately 1 by 4th, 60.4 mm thickness. The evidence of the contamination, the determination of the fracture properties of the rock may be influenced by air, water, and other fluids, contact with the internal cracks and pores surfaces. If the internal surfaces are contaminated by oil or other substances, their properties may be altered apparently and give the maximum test results. Of course, uh, cutting field is required with many type of specimens, preparation of the equipments. Clean water is a preferred field. Even so one must be cognizant of the effect of the moisture on the test specimen. While it may be impossible to do exactly duplicating the in situ conditions, even if they were known, uh, converted either effort should be made the simulate the environment from which the sample came. Generally, there are conditions to be considered. Number one, hard, dense rock and low porosity will be not normally be allowed to be moisture. This type of material is normally allowed to air dry prior to testing up to bring all the samples to be an equilibrium condition during the temperature above 120 degrees Fahrenheit, that is 49 degrees, is not recommended. And excessive heat may cause an irreversible changes in the rock properties. Some uh, shake and rock contaminating clay will be disintegrated, allowed to dry usually. Disintegrations of the diamond drill cores can be prevented by wrapping the core as there with drilled the moisture proof material such as a maximum foil or rather than of the sealed them in the maximum proof container. Mud, shale and rock containing vegetated maybe some the moisture content is too high. Most of the softer rocks can be poured out of usage, compressed air to the clean cutting to cool up the bed. These are the another test molded stable construction feed arrangement for cutting. These are the sample preparation items. Cooling water arrangements, heavy duty AC, single phase water. Polishing and lapping of the machine. These are the important ones. And then the units, this is a size for the different samples is concerned. Uh, EX size, AX size, and BX size and NX size. Standard sizes for drill bits. Straightness of the perpendicular flatness length, diameter ratio, and size of the specimens for strength and deformability testing. Straightness of cylinder sides. The two methods are used in this determine. Roll the samples on a flat, smooth surface and measure the height of the maximum gap between the specimen and the surface with the field gang. Straightening the predictability, flatness length, the diameter ratio, and size of the specimen. Rock specimens which are used in the various tests to determine the strength. And this is the assembly of determining the straightness of the cylinder surfaces uh, regarding regarding the maximum mm, maximum readings on the dial gauge and calculate the difference to repeat the same operations by rotating the specimen for every 90 degrees and obtain the differences the D90, 180 and 270. The maximum value of these four values shall be less than 0.5 mm and 0.002 mm. That is the verticality. The flatness of the end surfaces. The flatness of the end faces is determined by the setup similar to that for the cylindrical surfaces dial gauge. However, is now mounted near the end of the V block. Move the dial gauge holder horizontally along the end of the V block, maintaining good contact with the block. The record the dial gauge reading every 3 mm across the diameter. Plot the readings on an enlarged scale on paper and a smooth line through the points. The specimens exactly maintenance of the surfaces, the vertical tin as well as the surfaces. Dial gauge, specimen V block, assembly for determining the perpendicular end of the surface to the specimen axis. Samples after preparation of the before testing the laboratory, but perpendicular of the end face to the cylinder axis. So these are samples preparation. Dial gauge to measure the angle of block. These are the various type of cylinders and the straightening cylinder better than flattened and face perpendicularity. Straightness cylinder flattened end faces perpendicularity. Size and long diameter ratio for the particular specimen as per the ASTM the given here. So this table is giving the complete idea. Unix the compressor test. I by D ratio, how much required, and also Brazilian test and shear test. Number of samples to be tested, more than 5, more than 10, more than 5. Rate of loading 0.5 to 1 megapascals per second, 10 to 50 kilonewtons per meter. So you see this formula for the calculation purpose. A direct test, cylindrical diameter, indirect Brazilian test, tensile shackle, hollow cylinder, outer diameter, uniaxial by double sharing, uh, cylinder diameter to 25 L by D ratio, the cylindrical diameters, approximate diameter of the loading, these are the given here in this table. Triangular compressor test was 2.5, more than 5, 0.12 m megapascals, stress force by area in pascals. So ISRM, standard for testing rock specimens in laboratories. The specimen shall be right circular cylinder having height to be diameter ratio of the 2.030 and diameter preferably of not less than the NX one size, approximately 54 mm. The diameter of the specimen should be related to the size of the largest grain rock by ratio at least 110 is to 1. The end of the specimen shall be uh, that 0.02 mm and shall not be dependent upon the perpendicularly to the specimen by more than 0.001 radian at 3.5 mm or 0.05 mm 50 mm. The sides of the specimen shall be smooth, free of abrupt irregularities and straight to right within the 0.3 mm over the length of the specimen. The use of the capping material or ending surface treatment other than the mission in and it is not permitted. The diameter of the test specimen shall be measured nearest to 0.1 mm by averaging to direct measurement right angle to each other, at least upper height, the mid height and the lower height of the specimen. This is another experiment on our experiment. This is a protodiagno impact strength test. The protodiagno test was carried out with core sandstone samples. The determination of the protodiagno impact strength index about the crushing strength of the it give the crushing strength of the rock and also reflecting about the compressive strength of the rocks. For core samples, the number of blows was 15. The number of tests carried out for the core samples was 3. It was a found that the height of in the volumetric of the core sample was ranging between the 31 to 34 mm. Uh, Protodiagno test table as a core samples, weight of the samples and number of blows, height of the finest volumetric PSA and average age of the protodiagno strength index was found out to be by ranging between 8.28223 9.9677. The average of the strength indices was found out, which came to be 9.291. A number of blows given to sandstone samples was 20. Due to the less availability, sandstone samples test were under the for the determination of procedure for the impact test. So protodiagno test tables, sandstone samples. Uh, the determination of the rock strength from the slag durability test, protodiagno impact test, and Los Angeles laboratory resistance test. These are given Department of Mining. So another practical strata mechanism also given here. Here rock geometry of the coal mining represented by the satisfied rock mass of relatively weaker strength. Such stratifications are compound and unit in their version state before any kind of mining. Mining underneath both development and developing tends to be developed straight along weaker bedding plane, generated a bed separation called as a dilations by the action of gravity. The detailed mass stratums are supposed to the sag along its span width in the mining a wide opening. Subsequently, reduce the gap between the floor and the roof of the working called the convergency, sagging of straight the roof under the influence of the dilations and the subsequent convergency tends to exert certain load on the support system and remaining pillar sides either static or dynamic dilation, bed separation cause of the changes in stress from in situ state, which is in turn is the with the help of the instrumentation adding a startup moment and a subsequent assessment. Object of this study is to be identified correlated to parameters of strata mechanism such as dilations and convergency load, axial load, grain, stress, etc. by instrumentation so as to provide the base for the design support system to be prevent or control the collapse or failure or roof rib both safety economically. Parameters of the strata mechanism, dilations of the bed separations with the roof, convergence of roof, stress development on the pillar, strata development and axial loading of the roof bolt, load and support. So what are the instruments to monitor? Dilatations, thermal, multi-point borehole extension meter. These are the instruments. These are the instrument shown here. This is the roof bolting shown here. How to inserting inside. very clearly mentioned here, maybe. So while inserting the against the wall, it will be tightened. Installation of a roof bolting is given here. Drill hole using the appropriate bit. Drill hole using appropriate bit uh, to be at least twice the both of the length. Insert tap anchoring attached to the smallest indicator B to top of the hole. Used purposes designation designed and insertions and rod graduated to confirm anchoring a position. Check for firm anchorage. Insert lower anchor attachment to large indicator capital A 0.3 meter below the top of the reinforcement. Height using purpose of the graduated insertion of the rod. Secure reference tube. Position indicator A top of the given green brand to be level with bottom reference tube. Align to scale. Grip variable in position. Position indicator B top of the green brand to be held level with the bottom of indicator of A. Align to scale. Grip variable in position. Regard details at all the tell table. Site sign must be placed bearing the unique reference code for identification purpose. Giving the type of tell as it is a position date and time of the installation and anchor height. This information should be past relevant office, etc. The reading method by color. Report whole and part of the band weave. A the green and yellow red. 1 by 4th green yellow and red by scales. Report measure melted lining up with the reference to mark for each anchor. So this is a very clear mention here with color. Since the adoption of the called many precautions and improvements on the basic design have been test applied into different mining circumstances that triple height till the we developed where the full column bolts. So rotary tele uh, also this is the rotary tele mechanically installation in the roadway difficult to read where the height is more. This problem has been overcome for the single height by the developing the rotary tele. The device converted the roof movement into the rotation of the pointer rod and dial and magnify. The movement by faster. It is easy to read, easy to install, accuracy better than the one more. Small movement can be read easily within the reading visible from the below even in a 5 meter high roadway. The dial is subdivided into colored band corresponding to choose an action level. These are the anchor position of bolt. Auto warning telltale. So it is indicating clear well robot. So borehole extension meter. Keep the suspension cable under the tension. Uh, the reference tube can now be inserted into the bottom of the hole. The reference tube should be pushed fully into the hole. Position tube filtered with the indicator to the lower point and creep. Now the extension meter is ready for the working. Moment on the roof will be transferred to the reference tube. When the roof moment reaches the present signal auto warning, LED will be glow and start blinking. A multi-point borehole extension meter principle in a basic instrument designed that measures the strata dilution, bed separation, and a strategic version being placed inside the borehole. It is a remote instrument, so it can be used at both accessible and inaccessible locations. It is very helpful in a dead loaded and roof mass and subsequent design support the requirement of the working. Magnoscopic extension meter. It consists of the anchor, roof, protective casing, and transducers for displaced sector. The anchor are made or set up the strategic investment within the borehole through the anchor or road. Any dilations of these origins cause movement, and there is a cause of the resulting of displacement anchor by the help of the displacement. Uh, since cube cause change frequencies within the reduced by the rate and unit and further converted into millimeters. Application and features. It consists of the multiple anchor and feed another the following. Separation between the layer, propagation failure length, magnitude and location of the strata movement, ensure efficiency, bolting and influencing the extraction or development. So this is another principle of the sonic probe extensometer for the borehole operations. So it is very clearly mentioned borehole. The quick easy installation and profitable retardable uh, sonic probe and sensors, remote electronic readout, reading inner anchor, strain directly up to 20 anchor in the cone borehole, high accuracy and sensitivity. Ring magnetic positions on a central assist tubes are fired in the ground lubrication where the displacement is to be monitored. A probe incorporated a reading switch is made of the travel within the assist tube to the since the position of a magnetic outside the assist tube. The read switch tube on the entering the magnetic field, an activity of the budging or an indicator of the light. The single receiving instrument, the cable of the prompt, the market suitable interval for the measuring location of each magnetic from the end of the assist. is other features, same features. How sonic extension meter installations, reliable any number of props, documentation and monitoring. So documentation of the monitoring, analysis of the table, time, left hand, right hand, middle roof. The photographic, a particular drawn graphical drawings between the roof and floor. This is a roof bolting operation, remote convergence indicator. For monitoring of convergency in a GOF between the roof and floor, how much convergence is going on, vibrating wire type or pot meter type, phototype meter need buying wire from the instruments, location of measurement sites, falling immediately within the failure of the immediate roof. This is indicating of the principal operation of the remote convergency indicator. So this is another installations work. The instrument is made fixed and vertical between the roof and floor by the helping of the base pipe and extension rod. The position of the stretch spring rod load any closer of the roof and floor makes the spring and displaced causing change in the frequency resistance and ultimately giving the electronic reading convergency through the wire from a safe and predetermined devices. Documentation, place of monitoring time, convergency, rate of change in convergence estimate, minus it or not. Position of working place remarks. Analysis of may be carried out with the drawn parameters convergence rate of changes. Convergency, that is the time lag for the roof fall, area exposure, a distance from the GOF edge, and with an appropriate roof. Load supports. This is a solid load cells and amular load cell type of load cells, vibrating rock block, mechanical, hydraulic, strain, vibrating wires. The load cell is a transducer working in the vibrating wire pipe principles. In the, it has there is a stretch where house metal cylindrical which uh, plug by any electrical plus high energy. Change in the load carried on the cell causing change in the length of the wire resulting uh, in a variation of the frequency of variety of the wire. As the load increases, frequency decreases according to the vice versa. Stress measurements, coming to the stress measurements. Stress are the general pressure associated with every known in the stratum by principles dimensions. Type of in situ stresses are there, induced stresses are there, horizontal stresses and vertical stresses, stress cells, uh, stresses, earth pressure cells, pillar strain meters, crusher meters. These are the instruments they are using by uh, find outing the cells, load cells, like the stress cells, you can say. So procedures for the dimensional measurements. So core pillars inside the cell is inserted. Installation of the pressure, find out in the pressure. So this is the model. It's a crack meter, rock bolt strain gauge meters. This is the rope bolts operation. Theory of rope bolt operation. This is one model. This is another model. Three theories are the skin control. It is a strong massive roof that is essentially self-supporting cracks, joints, crossbeds, or silkiness can create occupational hazards. Loose rocks at the skinny and opening in the environment. The function of the bolt is to be prevent a local rock fall, not to be prevent a major collapse. A pattern of relatively light, short rope bolts usually sufficient. Skin control is also an important secondary function of the root bolt in a weaker ground. Suspension in many mines a stronger unit is a largely self-supporting overlies in a weak immediate roof layer in these circumstances. Roof bolts act as a suspended the weaker layer. Experience has shown that roof bolting are extremely efficient in the suspension mode. Suspension become the more difficult if the weaker layer more than 3 feet thick. The coal mine roof rating somewhat quantity effects is through the strong bed adjustment. The traditional dead weight loading design approach is generally appropriate for suspension of applications. Beam building, where no self-supporting bed is within the reach, the bed beam, the bolt, or act by maintaining the friction and bedding plane, keying together block fracture rock, and controlling the dilution field or generalized. These three are the generalized principles for the roboting is concerned. This is the anchoring of another method. Suspension supports. Then this is a anchored bolt structure complete. Various installation procedures from the top to the first stage and second stage and third, and fitting to the bolt. The fourth stage, one, two, three, four stages are showing here. This is the style of the bolt heads. Different type of styles of the bolt heads are shown here. So resin capsule bolt inserting to the insert. So these are the um, roof boltings and different type of laminated roofs. How keystone theory and suspension theory. How the bolt is inserted inside to the roof and the sequences. These are the lectures you are completed today. I hope you understand the class today class. You are enjoyed. Uh, thank you.